Hello everyone. So in the last video, I showed you how you can load in your diamond dataset and do some data transformation to change the object data type into a numerical data type, which can be used for the purpose of training the support vector machines model. And in this video, I want to show you how you can train your model, split your data into test and train dataset, and also do the prediction. And we are also going to look at different kernels functions later. So without further ado, let's look at how we can do it in the next step. And if you back to our Python notebook, the next thing that we want to do is to train our model. So to do that, we have to import the Scikit-Learn library. SVM and pre-processing, and then we also want to say from Scikit-Learn model underscore selection import train test split. Go ahead and run this. So you can see that we imported SVM, which stands for support vector machines, and then we also imported the pre-processing for the scaling of the data later, and we also import the train test split to split our data into train data and test data. So the next thing that we want to do is to define our x and y, which is the input variables and the output variables. So to do that, x is equal to df.drop price, and then 1. X is equal to pre-processing.scale x, and then our y is equal to df price. Go ahead and run this, and you can look at actually split our data into x train, x test, y train, and y test with using a train test split, and then x, y, and then the test size is equal to 0.3. So in this case, we split the data in terms of 70% of the data will go to train data, and then we keep the 30% of the data as the training data. Sorry, the testing data. So let's go ahead and run this, and then next we are going to define our model. In this case, our classifier is equal to svm.svr. So in this case, we are using regression, and therefore we use SVR. And if you want to use it for classification, then we will use SVC. But for this case, we're going to say SVR, then kernel is our kernel functions. We want to say linear. Let's try it first with linear, and then after that we can change it to different kernel functions and then compare the accuracy. So after that, clof.fit, and then x train, y train. As I mentioned earlier in the video, sometimes the disadvantage of support vector machine is that it will take longer time to look for the best separation hyperplane, and therefore it will take a little bit time in terms of training of the model. But however, most of the time, the advantage is that it will give a quite high accuracy compared to other model. So I'm going to stop here until the model has been trained, and then I will come back in a short while. Alright, so our model has been successfully trained, and then the next thing that we want to do is to check how the score or the accuracy of our model. So to do that, we can say that confidence is equal to cof dot score, and then x train y train, and then we can print our confidence. So you can see that the accuracy of our model with using the linear kernel function is around 85.85%, which is pretty high. And which can actually come to the last step of our machine learning, which is a prediction in this. So for the last step, we actually want to do some prediction with using our train model. To do that, we can actually run this line of code. So for every single row in the test data, we're going to print out what the predicted value is, and also what will be the actual value. So go ahead and run this. So you can see that it's printing out every single line in the test data of what the model is predicting against the actual value in the data set. So even though our accuracy is quite high, but then we still see some unreasonable number. For example, you can't have negative number for the price, which means that linear kernel function might not be the best kernel function that you want to use. So in order to change to other kernel function, you can refer to the Scikit-Learn documentation, and if you go to regression, you can see that there are several kernel functions that you can use, for example polynomial, RBF, or sigmoid. Let's say we want to change to RBF, and it's very simple to do so. What you need to do is just copy the classifier and then paste here, and then change to RBF, and go ahead and run this. And then we also want to check the accuracy score. Go ahead and run this, and then after that we also want to do a prediction with using the RBF model. So now you can see that we have our model that is being trained with the kernel RBF kernel function, but then the accuracy score is not that high as compared to the linear function. For this case, the RBF only score 50.36%, but then if you inspect the predicted values, is better than the linear function in terms that you don't get negative value. So as homework, you can just go ahead to try other different kernel functions in this dataset to hopefully get one that is most logical and also give you the best prediction accuracy. So I'm going to stop here for this tutorial. And if you like my video, please hit the like button and subscribe to my channel, and I will show you more machine learning techniques in the next video. See you.